Hello friends, this is Jim with Science Talk. A little bit of interesting news from the realm of geophysics. Africa is splitting in two. A piece of East Africa is expected to break off the main continent in tens of millions of years, so it's not going to happen tomorrow. Where? You probably might have already guessed, in Kenya's Rift Valley. There is a giant gaping tear that's literally opening up in the ground. And this opening is resulted after periods of heavy rain and, most importantly, seismic activity. This enormous crack appeared March 19th and measures more than 50 feet across and several miles long. And it is growing longer. This rift is likely a sign of things to come as the plate tectonics under Africa rearrange themselves. The majority of Africa sits on top of the African plate. However, a long vertical piece of eastern Africa lies on top of the Somali plate. This juncture where the two plates meet is known as the East African Rift. And this rift stretches 1,800 miles, 3,000 kilometers. Which, for those in the US, that's approximately the distance from Denver to Boston. To avoid confusion, researchers call the giant African plate the Nubian Plate. So we in essence have the Nubian and Somali plates are being split in two. Okay. So this is according to Lucia Perez Diaz, who is a postdoctoral researcher at the Fault Dynamics Research Group at Royal Holloway, University of London. And Dr. Diaz wrote a piece in The Conversation discussing the situation in Africa. The East African Rift Valley, as this region is known, I just mentioned that, formed when the Somalian and Nubian plates are pulling apart from the Arabian plate. The eastern branch of the rift passes through Ethiopia and Kenya. The western branch forms a giant arc from Uganda to Malawi. So, a little mechanisms for you. Here's how the two plates split apart. The lithosphere, that's basically the part containing rocks and so forth. You have atmosphere, hydrosphere. Lithosphere is the portion of the planet that's made of rocks, is broken up into tectonic plates made up of the Earth's crust and the upper part of the mantle. When the lithosphere experiences tugging forces, it becomes thinner until it eventually ruptures. This rupture has already led to the formation of the Rift Valley. Think of what happens when you have a piece of taffy and you pull it, start pulling it apart. What happens? It gets really thin until it breaks and you have two pieces of taffy. That's kind of the analogy here with this situation. The rupture process is often accompanied by seismic activity because the plates are moving and volcanism. In the East African Rift's case, a large mantle plume under the lithosphere is weakening it, allowing it to stretch, Professor Diaz says. Rifts lead to recognizable land formations. That is a series of depressions surrounded by higher ground. The East African Rift has a series of rift valleys that can be seen from space. Not all these rifts formed at the same time. They started in northern Ethiopia about 30 million years ago, spread southward through Zimbabwe, at an average rate of 1 and 2 inches, between 1 and 2 inches per year, which is about 2.5 to 5 centimeters per year. And of course, the East African Rift Zone is where the first humans are thought to have originated and is often referred to as the cradle of human evolution. The next story involves Antarctica and North America, where they were once attached. Remote Antarctic rocks hold strong new evidence that parts of Antarctica and North America were connected more than 1 billion billion with a B, years ago. An international team of scientists found that the combination of lead isotopes in rocks that were protruding out of the Antarctic ice is the same as in rocks from a rift that cuts across the United States. Now, isotopes are basically different forms of the same element. An element is identified by the number of protons found in its nucleus. So if an element has 6 protons in its nucleus, that identifies it as carbon. Carbon always has 6 protons in its nucleus. What changes is the number of neutrons. So carbon-12 basically contains 6 protons, 6 neutrons. To get the what's called the atomic mass, you add, in general purposes, you add the number of protons and number of neutrons. So differing isotopes have, in essence, different number of neutrons. So carbon-13 still has 6 protons, but will have 7 neutrons. Carbon-14 still has 6 protons, but now has 8 neutrons. If you change the number of protons, you get a different element. That's why if you follow the decay series, uranium decays into lead eventually. Because what happens as it's decaying, it's giving off beta particle, which is basically a couple of protons at a go. And along with alpha and gamma particles, but the beta particles, the heavy stuff given off. And eventually by giving off the protons, it's no longer uranium, it's becoming another element. And the half-life is defined as the amount of time it takes for half of the material to decompose into something else. So they measured the different isotopes of lead to make this finding. The lead researcher in the study, Stacy Lowy, is a geochemist at California State University, Bakersfield. Basically says, I can go to the Franklin Mountains in West Texas and stand next to what was once part of Coates Land in Antarctica. That is so amazing. That's her quote. Geologists have known for decades that Earth continents move around as part of the tectonic plates that join together like puzzle pieces to make up the planet's crust. Now, Alfred Wegener, back in the early 1900s, postulated that he saw South America, he saw Africa, and he looked at the coastline and said, looks like they fit together. And so he postulated that the continents were joined. And he was kind of like, well, you're an idiot. What are you talking about? It's rocks. Rocks don't move. Well, we now know, thanks to our studies of the mid-oceanic rifts and so on, where we see the magma coming up, pushing apart the different plates, we now know that Wegener was correct in that assessment. He just did not have the means to verify his hypothesis. So, because now geologists now know that the different continents were joined together because of the movement of the plates, you can now compare features on one mountain, such as mountain ranges, coastlines, and fossils, to those on another, and they can show how they were once attached. At various times in Earth's history, the continents have been stuck together in huge land masses called supercontinents. The supercontinent Pangaea formed about 250 million years ago, but scientists think ancestral North America and East Antarctica were joined in a much earlier supercontinent called Rodinia. The new find supports this idea. Okay, further evidence. The North American mid-continent rift system extends from the Great Lakes to Texas. This rift, which is approximately 1.1 billion years old, apparently represents a failed tectonic attempt to split the ancestral North American continent of Laurentia. A failed separation, basically. Past research of the rift found that volcanic rocks of the Upper Peninsula of Michigan are the same age as rocks barely protruding through the ice in Coates Land, which is a remote part of Antarctica south of the Atlantic Ocean basin. Moreover, in further support, they have similar chemical and geologic properties. Now, this leads us to an interesting little side story here that I'm going to bring to the fore. The new findings help suggest that Coates' land block was linked with the part of Laurentia near West Texas 1.1 billion years ago, as I just said. About 100 million years later, this block apparently crashed into the ancient southern African continent of Kalahari along Antarctica's Maud Mountain Belt. This represents a continuation of the Grenville Mountain Belt of eastern and southern North America. At about the time Antarctica was linked with North America and colliding with Kalahari, Earth was experiencing a number of other monumental changes. The Pacific Ocean basin was just about to open. The planet may have been covered with glaciers. This is not known for sure, but is hypothesized, in a time that's now referred to as Snowball Earth. I'll be discussing more about that in a moment. And also, complex multicellular life was appearing for the first time. The study, which I just described about how evidence for North America and Antarctica were once linked together, is in the journal Geology. So, what is the Snowball Earth? The Snowball Earth hypothesis in geology and climatology is an explanation first proposed by American geobiologist J.L. Kirschvink, suggesting that Earth's oceans and land surfaces were covered by ice from the poles to the equator during at least two extreme cooling events between 2.4 billion and 580 million years ago, ending just before the Cambrian Explosion got underway. The Cambrian Explosion. The Cambrian Explosion is that great period in evolutionary history where there's a huge radiation of all different types of forms. All the different phyla that we are familiar with today appeared during the Cambrian Explosion, as well as other phyla that are no longer in existence. This has occurred about 541 million years ago. But Ediacaran life forms existed during this time period of the Snowball Earth. Okay, what's the Ediacaran? The Ediacaran biota consisted of tubular and frond-shaped, mostly sessile organisms that lived during the Ediacaran period, which is about 635 to 542 million years ago. It ended just before the Cambrian Explosion. Trace fossils of these organisms have been found worldwide and represent the earliest known complex multicellular organisms. The Ediacaran biota may have radiated in a proposed event called the Avalon Explosion 575 million years ago, after the Earth had thawed from the Cryogenian period's extensive glaciation. So the Earth started to come out of this snowball situation that is hypothesized, and the Ediacaran started to do some radiation, developing new forms, before they finally apparently disappeared from the record. The biota largely disappeared with the rapid increase in biodiversity known as the Cambrian Explosion, which I just described to you. Most of the currently existing body plans of animals first appeared in the fossil record of the Cambrian rather than the Ediacaran. For macroorganisms, the Cambrian biota appears to have completely replaced the organisms that dominated the Ediacaran fossil record, although relationships are still a matter of debate. The Ediacarans may be related to Porifera or Cnidaria. Porifera, typically the sponges, which is sometimes referred to as metazoans, and they're really kind of a side branch. So it is possible that one hypothesis is that the Porifera are perhaps related to the Ediacaran. Cnidaria include things such as jellyfish, hydra, obelia, organisms like that. So they could be related to the peripherans or just a separate extinct lineage of themselves. We don't know. What is the evidence for this? The evidence for this hypothesis is found in old rock that preserves signs of Earth's ancient magnetic field. Measurement of these rocks indicate that rocks known to be associated with the presence of ice were formed near the equator. In addition, there is a 45 meter, about 148 feet thick layer of manganese ore in the Kalahari Desert with an age corresponding to the end of the 2.4 billion year Snowball Earth period. Its deposition is thought to have been caused by rapid and massive changes in global climate as the worldwide covering of ice melted. Two important questions arise from this hypothesis. First, how once frozen could Earth thaw? Second, how could life survive periods of global freezing? One proposed solution to the first question involves the outgassing of massive amounts of carbon dioxide by volcanoes. Okay? Global warming, which could have warmed the planetary surface rapidly by enhancing the planet's so-called greenhouse effect. Especially given that major carbon dioxide sinks, rock weathering photosynthesis would have been dampened by a frozen Earth. One possible answer to the second question may lie in the existence of present-day life forms within hot springs and deep-sea vents, which would have persisted long ago despite the frozen state of Earth's surface. Many biologists are of the opinion that the first life forms were probably found in regions where oxygen is not prevalent, because oxygen took a while to build up in sufficient quantity in the atmosphere. So places like hydrothermal vents, chemosynthesis, hydrogen sulfide abound could be where we see the first organisms, as well as, say, the thermophiles, bacteria that like it really hot, or the acetophiles, bacteria that like very acidic conditions, such as hot springs and so forth. Go to Yellowstone. You've got a lot of what's called archaean bacteria there that are really don't like oxygen, but they like anoxic situations at high temperatures, acidic conditions, and they thrive quite well in that. Alternatively, meltwater ponds on the surface of the ice or warmer refugia near active volcanoes may have provided sanctuary to early life forms. Much debate continues to surround this idea, and there are those scientists who have voiced their support for a competing hypothesis called the slush ball Earth hypothesis, which is, in essence, a counter premise to the snowball Earth hypothesis. The slush ball Earth hypothesis, developed by American geologist Richard Cohen, contends that Earth was not completely frozen over during periods of extreme glaciation in pre-Cambrian time. Rather, in addition to massive ice sheets covering the continent, parts of the planet, especially ocean areas near the equator, could have been draped only by a thin, watery layer of ice amid areas of open sea. Slush. We actually, in the article, we refer to that as slush ice. Okay? Then you get frazzle ice and so on. But you have actually called slush ice. So it's like what happens when snow starts melting. It gets that slushy look to it. You know, you make a snowball. It's very wet and heavy, and you can squeeze the water out of it. That's kind of what's being proposed here. Under this scenario, photosynthetic organisms in low ice or ice-free regions could continue to capture sunlight effectively and survive long periods of extreme cold. Anyway, I thought these stories were extremely interesting. I wanted to share them with you. It's always nice to talk about things other than climate change, which can be a bit depressing, but it is the nature of what it is. It's very fascinating to see or to ascertain new evidence for what happened all those hundreds of millions of years ago and billions of years ago. Stephen Jay Gould, the late professor of Harvard, Stephen Jay Gould wrote a wonderful book called Wonderful Life. And he talks about the Burgess Shale, which is a famous fossil trove of all these amazing fossils that's happened right at the Cambrian Explosion. We just see all sorts of really interesting forms there, including what most likely may be the ancestor of all chordates. Chordates include humans and basically all vertebrate life forms. It's a wonderful book. It's my favorite book by Gould. I think his most important work is The Mismeasure of Man, where he basically slams intelligence testing methods and so forth. But The Wonderful Life is a great read. It's fascinating, and it describes a lot of the Cambrian Explosion. So anytime we get pieces of information, it helps us understand evolutionary relationships. That's always cool. And the Ediacarans were really a first multicellular life forms. They did not persist, or perhaps they did persist and became what we call sponges, the peripherans. This is how science is. It's ongoing. We learn, we get evidence, we learn, we debate. We say, oh, it indicates this, it might be this. New evidence says, well, okay, it supports that contention, or you have to rethink. Science is an ongoing process, and it's just so fascinating. So, if you like this video, please share, please subscribe, hit the bell. Please go to patreon.com, become a patron. Look for Science Talk with Jim Massa. If you're already a patron, I thank you for your support. Please tell others of my work. Through word of mouth from viewers like you is how this channel will grow. Thank you for your time.